honestly, I don't know if this is supposed to be solved with momentum or not, but have you talked about, or have you seen anything about momentum yet?
I don't know. I was gone all last week, so
Yeah,
I feel
okay.
like I've been gone for a month.
So, impulse and momentum. Those are like two big things. So momentum is pretty simple. Actually, impulse and momentum are way easier than forces. It's just a matter of actually learning it so you know what's going on.
Okay.
So P, little p is momentum, and it's equal to the mass times the velocity. So if an object of 5 kilograms is moving at say 3 meters per second, it has 5 times 3 was 15 kilogram meters per second of momentum.
Okay.
Okay, and then impulse is J. It's equal to a force, well, an average force times a time. And what that means is you'll have like a graph like this. Whatever the average force of that graph is for that segment of time, from here to here, times that would be your impulse. So actually what it is it's the area underneath the force time graph. That make sense?
Mm-hmm.
So if you want to find impulse, you find the area under the force time graph.
Okay.
Sometimes to simplify it, they'll give you an average force, which means if you took that force and spread it out equally, you could just make a rectangle, and you can just find the area of the rectangle. Right?
Okay.
So, say we had this object going 5 kilograms going 3 meters per second, and there was a force that looked like this that acted on it. This is 4 seconds, 0 seconds, 1 newton. What would be the area under the force versus time graph?
Let's see. Just be 2, right?
Yeah, so you'd have 1 newton times 4 seconds, and then since it's triangle divided by 2, so that would be 2 newton seconds.
Okay.
A newton is a kilogram meter per second squared, so when you multiply it by a second, that just cancels. You end up with kilograms meters per second, right, which is the same units.
Okay.
So J is the change in momentum. Okay.
Okay.
So you started out going with a 5 kilogram object going 3 meters per second, and now you changed the momentum by 2. So the final momentum will be 7, right?
How come it's 7?
So you, oh, sorry, 17. Okay, you started with this momentum, and then that you applied an impulse of 2 kilograms per kilogram meters per second, which gives you, which basically you just add on to your momentum.
Okay.
So it's 17.
Alright.
So if you wanted to find the velocity of the, it's still 5 kilograms, right? So if you want to find the velocity, it's still mv. So 17 would be equal to 5 times the final velocity. 17 fifths would be your final velocity, right?
Okay.
So that's impulse and momentum in a nutshell. Momentum is just the mass times the velocity. And then the change in momentum was called the impulse. And it's equal to the area under the force time graph.
Okay.
So real quick, we can look at that question. First one. It's got a graph that goes for 6 seconds, right?
Yeah. Starts at 0 and goes up to 10 newtons. By the time it gets to 4 seconds,
And it drops to 0, right?
drops to 0 until 6, yeah.
Okay. So, and then it tells you about the object before.
5 kilogram object initially at rest at the origin is subjected to the time varying force shown in the figure.
Shoot. How far does it go, right?
Yeah, what is the object's velocity at 6 seconds?
Oh, okay. Good. So we don't care that it's at the origin. We just want to know how fast it's going. So its initial velocity is what?
0.
Okay. So that's its momentum before would be what?
I don't know.
So momentum is mass times velocity. So it's its momentum.
Okay, so 0.
Yep. So that's its initial momentum. Okay. Change in momentum is J, which is equal to the force times the time. So what's the area under this graph?
Well, let's see, it's 10 times 4 is 40, so it's 20
Okay, so a change in P will equal 20.
newtons.
Yeah, Newton seconds. So what's the final going to be? And then it's a change in P equals P final minus P initial.
I'm lost.
Oh, okay, so don't worry about this stuff. I just added extra things here. So you started with a P of 0, or momentum of 0. That momentum changed by 20.
Okay,
So what is it now?
20.
Okay. So it's that simple. And that's why I wrote this. A change in P equals P final minus P initial. So 20 equals 20 minus 0.
Okay.
Okay, so that's its final momentum. So how do you find its final velocity?
I can't remember.
Alright, so the mass is still 5 kilograms, right?
Mm-hmm.
But what's the velocity? You know that P final equals M times V final.
Okay.
So 20 equals 5 kilograms times V final.
Okay, so it's 20 fifths.
Yeah, which is 4. Okay. So you started out with a mass times a velocity. You added some change to that. And you end up with a mass times a velocity.
Okay. What does W represent?
Oh, this is 20, sorry.
Oh. Okay.
It's really fast, 20.
I'm never gonna remember all this. Okay.
So if it's a momentum problem, you're gonna be given, it'll be dealing with mass and velocity, and sometimes like an average force. You find the momentum before, then you take the impulse, add that to it,
Okay.
and that'll give you your momentum after.
Okay.